Okay, in the last section, I basically described the legislation that's applied to cars and vehicles sold in Europe. And I mentioned, for example, the Euro standards, which limit the amount of harmful emissions that can be produced from the vehicles. Now, to ensure that a car passes those emissions standards and can be sold in Europe, they need to be tested against a standard test. And those standard tests are called drive cycles. So basically, a vehicle is taken into a test house and is submitted to the same test procedure to measure the emissions to show that it's safe, to ensure parity amongst all vehicles. Now, the drive cycles that kind of implemented can range worldwide. So again, I'm taking a UK and European perspective of this. So how were the emissions measured? They have changed only very recently, but it's still worth talking about how they were done. And so as I said, the emissions are tested against the standard cycle, and this is how it was done. This is what's called the new European driving cycle. This was introduced in 1997. And basically replaced by a new cycle in 2007. But this is what it used to look like. So you can see basically the vehicle, the way the vehicle is tested is, first of all, it's kind of pre-conditioned. So it uses standard oils and fuels. Any consumer electronics turned off. It's what's called soaked. So it's put into an environmental chamber, and the car is soaked overnight so that it's at a predetermined temperature between 20 and 30 degrees C. So the same vehicle is always tested, all vehicles are always tested at the same temperature. It's then brought into the test house, and then basically either a robot or a qualified human driver basically drives against this cycle. So you can see here you've got vehicle speed against time. And what they do is they just drive along this cycle. And the gears, they're told when they have to shift gears to stay on this curve. And whilst it's driving along here, they measure the amount of carbon dioxide that the vehicle's producing and the amount of harmful emissions that the vehicle's producing, and then they add it all up at the end and check that it's below the limits. If it is, then they can that they're permitted to sell the vehicle in, for example, Europe, which is this cycle was somewhat one for Europe. However, this cycle's no longer appropriate. The reason for that is there's obviously some criticisms about this. You can see that these are quite straight lines, so the vehicle had quite low accelerations, which is compared to real world driving. It's got constant cruise speed, so very few people drive like this in the real world. So mainly all these criticisms are the fact that this drive cycle, which had been developed, didn't reflect real world driving. So it's no good basing your emissions on this test if these aren't the emissions that are going to be released in the real world. There's quite a few idling events, and perhaps kind of most importantly, most recently, it can be cheated. Okay, and obviously this VW scandal kind of wasn't the reason this test was changed. They were in the process of changing it in a way, but I think it kind of increased the urgency to replace this cycle. So probably worth spending a little time talking about that and what happened with so-called Dieselgate. Basically in 2015, the EPA, or the Environmental Protection Agency in the US, accused VW of cheating on diesel emissions tests. VW didn't deny this, they owned up to it, and the kind of fallout of that is fairly well documented. That their share prices crashed, they had to pay huge fines, and customers lost confidence in the brand. In the UK, the next year, the Department for Transport commissioned a study to determine if VW were alone in using this. And, you can go and get a copy of this report, read it. I think it's interesting. It's quite a good read. And I pulled out some of the highlights for you on the next couple of slides. So, part of the reason this is done is quite interesting, is that since 2000, the year 2000, the emission limits of NOx have decreased by 85%. However, the air quality hasn't improved based on local monitoring. This is because the actual NOx emissions have only decreased by 40% over the same period. So something's not going right here. So this is a graphic that shows this. So these are going through the various European standards. So in Euro 3, you were permitted half a gram per kilometre. You can see how that's decreased down, going up to Euro 6. But the what's shown in the bigger cloud bubble is the actual amounts. So you can see, although this has gone down, and say 85%, this has only gone down 40%. And not saying that cheating is necessarily the culprit for this, but more the fact that the cycle isn't representative of real world driving. So although this is going down in the lab, it's not going down in the real world. They also did, check to see if any cars were, aside from Volkswagen, were cheating the tests, and they didn't find that they were. And so they ran a couple of tests, and what they did, or one of the things that they did, is they first of all just ran the cars against the standard NEDC test, which was the test at the time, and they ensured that all the vehicles that they were testing met the NEDC under the prescribed conditions, so the soaking of the vehicle, using the correct fuel and lubes, etc., etc. They then applied a couple of other tests. They ran the NEDC at what was called a hot cycle, so basically with the engine warmed up, so the vehicle wasn't soaked. They ran it hot to see if it made any difference. And for this vehicle, which doesn't have a cheat device fitted, you can see that the emissions are pretty negligible across the range of tests. And the orange line shows that, okay, there's a little spike of emissions here, but generally they're quite low. And also they ran it in reverse, so to try and trick the car into thinking that it's not being tested, they ran it in reverse. So the green line is actually going back this way. And again, you can see, okay, there are some spikes in here, but generally for this vehicle, it meets the limits. Whether it's run hot, whether it's run cold, hot, forwards, backwards, it behaves as it should. This is the test for a car with a cheat device, and you can see that the emissions are much higher, whether it's run hot, and especially when it's run in reverse. So, because obviously when it's running in reverse, the engine doesn't know or doesn't think that it's being tested. So the cheat device isn't activated, so the emissions are a lot higher than they would be to cheat the test. So this is what the report found. Obviously, as they suspected that certain vehicle manufacturers were cheating the emissions test, but they could be easily found out by running the test backwards, basically. So to kind of readdress some of the criticism of the NEDC, from September 2017, the NEDC was replaced by what's called the World Harmonised Light Vehicle Test Procedure, or WLTP. And the WLTP is designed to be more dynamic, I suppose is the word, and more realistic for real-world driving conditions. And you can see it here, and basically it's a lot more wriggly, I guess, than the NEDC, which was just a series of straight lines. And the idea is that this attempts to model real-world conditions better. And the WLTP was constructed from over 765,000 kilometres worth of data, collected from, I think it was 10 or 11 countries and a range of continents. And the idea is that you're ironing out everything but the drive behaviour here. So this is meant to be the average driving behaviour of a typical citizen worldwide. And also because they've learned from their lesson that the emissions that a vehicle produces under strict lab conditions, and that's kind of regardless of the applicability of the tests that it's being measured against, it will always give different results in the real world when you have different driving behaviour, different topography, different traffic conditions, etc., etc. So this is why the WLTP will be complemented by an additional test, which is a real driving emissions test, or the RDE. And what the RDE is it's exactly that. It measures the emissions in the real world, and it does that using a portable emissions measurement system, or PEMS, on public roads. So this is an example of a vehicle under test in a WLTP. So this is a test chamber. The vehicle is put on a rolling road, is cycled through the test, and the emissions are collected. And here's an example of a vehicle out on the road being tested under RDE conditions. So you can see the PEMS kit on the back, the exhaust data is being collected and analysed. And the vehicle isn't just taken out and tested in any old road conditions. There's still certain criteria what the vehicle has to do. It has to drive on what are called some urban roads at low speeds, some rural roads at medium speeds, and some motorways at high speeds. And there's all these kind of various legislation that the test has to be more than a certain period of time, and the elevation change can't be too much or too little, and you've got to have certain percentages of low, medium, and high speeds, and etc., etc. So it's quite a lot of what is needed to make a valid RDE test. But the point remains is that the whole idea of this is to test a vehicle in the real world under real conditions, and ensure that it does comply with the legislation that's when it's tested against a standard test in the lab. And initially, because this is the first time the test has been introduced, the manufacturer has been granted a conformity factor of 1.5. And what this basically means is that on the real world, they're saying that the emissions can be up to 50% higher, partly to allow for the inaccuracies of the PEMS kit, but also to give, the manufacturers a little chance to get their house in order, and ensure that what is the emissions in the lab are the emissions that they get in the real world.